Hello everybody, welcome back to my channel. So in our earlier video we have seen about the introduction to boundary layer theory and also various thickness related to boundary layer theory like displacement thickness, energy thickness, momentum thickness, etc. And in this video we will solve numerical problems related to the displacement thickness, momentum thickness and energy thickness. So the question is find the displacement thickness, momentum thickness and energy thickness for the velocity distribution in the boundary layer given by u by u is equals to 2 into y by delta minus y by delta whole square. So this is the velocity distribution given to us. He is asking us to calculate the values of these three thickness. So before we move into the actual calculation, first we will try to simplify this u by u. So actually what is given is 2 into y by delta minus y by delta whole square. So if we open the brackets and simplify, so 2 into y by delta becomes 2y by delta minus y by delta whole square becomes y square by delta square. So from now this simplification we will use for our calculation, okay, because if you use this directly, it becomes clumsy and we may go wrong somewhere in the calculation. So first let's simplify the u by u itself, then we can put it in the relevant formula for thicknesses. Coming to the first one, displacement thickness. So the formula for displacement thickness is given by delta star is equal to integral 0 to delta 1 minus u by u into dy. So this equation is already given in the earlier video, kindly check out. So it is integral 0 to delta 1 minus, in the place of u by u I will be substituting this value, which is 2y by delta minus y square by delta square into dy. So if I simplify this, it becomes, I'm trying to remove this minus. So minus into 2y by delta becomes minus 2y by delta. Minus into minus becomes plus y square by delta square dy. Now I'll try to integrate this and I'll apply the limits. So integral of 1 is y, because we are doing with respect to dy, minus 2 into integral of y is y square by 2. So it is 2 into y square by 2 into, already in denominator there is delta, so I am putting delta here, plus integral of y square is y cube by 3. So y cube by 3 into, already there is delta square in the denominator, so into delta square, limits are from 0 to delta. So if I apply, if I simplify this, I'll get y minus 2 and 2 I can get cancelled. So it becomes y square by delta plus y cube by 3 delta square. So just apply the limits of 0 to delta. So when you substitute 0, everything becomes 0. So the upper limit is delta. So it is in the place of y delta, delta minus delta square by delta plus delta cube by 3 delta square. Again here, when I can cancel, I will get remaining with 1 delta and delta square and delta square. Here another delta will remain. So it is delta minus delta plus delta by 3. And finally, if I take the LCM, and these two will get cancelled. So if I solve, it becomes delta by 3. Okay, and for the same velocity distribution, let me start doing for momentum thickness. The formula for momentum thickness is given by integral 0 to delta u minus u into 1 minus u by u dy. So the earlier formula was only 1 minus u by u dy. Here it is u by u into 1 minus u by u dy. So in the place of u by u, again substitute 2y by delta minus y square by delta square into 1 minus, again u by u is 2y by delta minus y square by delta square dy. So this is little bigger, so we have to solve it carefully. So first I will write this term as it is. Here I will multiply with minus. So 1 minus, again this becomes 2y by delta, again minus into minus becomes plus y square by delta square dy. Now we will try to multiply each and every term with all the other terms of this equation. Similarly, this also with all the other terms of this equation. Okay. So 2y by delta into 1 becomes 2y by delta. 2y by delta into minus 2y by delta becomes minus 4y square by delta square. 2y by delta into plus y square by delta square becomes 2y cube plus delta cube. So I multiplied 2y by delta with all these three terms. Now I should multiply minus y square by delta square with all these three terms. So if I multiply minus y square by delta square by 1, I will get y square by delta square. And if I multiply minus y square by delta square with minus 2y by delta, I will get plus 2y cube by delta cube. And if I multiply minus y square by delta square with plus y square by delta square, I will get minus y power 4 by delta power 4, because plus into minus is minus. Now anything to simplify in this equation, we will simplify. So you can see here I have 2y cube by delta cube, here I have 2y cube by delta cube, so it becomes 4y cube by delta cube. And yeah, so the equation becomes 2y by delta, and here also I have 4y square by delta square, here I have y square by delta square, so both are minus minus, so it becomes minus 5y square by delta square plus these two I don't know, we are adding these two. So 4y cube by delta cube minus what is left over, y power 4 by delta power 4 into dy. So now integrate this. Integral of y becomes y square by 2. Integral of y square becomes y cube by 3. Integral of y cube becomes y power 4 by 4. And integral y power 4 becomes y power 5 by 5. And again a simple basic calculation, cancel out 2 and 2 will get cancelled, here 4 and 4 get cancelled, write whatever is left over here, apply the limits. So in the place of y you will substitute delta, so we will be ending with this value of delta minus 5 delta by 3 plus delta minus delta by 5. So if I can take out the LCM of 3 and 5, the LCM is 15, and just if I do the calculation, you get theta value to be around 2 delta by 15. And finally is the energy thickness. Energy thickness formula is given by delta double star is equal to integral 0 to delta u by u into 1 minus u square by u square into dy. This equation is also given in the earlier video, which is the introduction to boundary layer video. Kindly check out there. And now if I substitute the value, it is integral 0 to delta u by u is 2y by delta minus y square by y square into 1 minus in the place of u square by u square. See, it is u square by u square means what? It is u by u whole square. What is u by u for us? 2y by delta minus y square by delta square whole square. Now first term don't disturb because we will be solving the second term. So into 1 minus, this is a minus b whole square. This is A and this is B, what we learnt in our basic level of algebra. So A minus B whole square formula is A square, which is 4y square by delta square, plus B square, which is y square by delta square whole square, minus 2ab. So 2 into these two terms, we will get 4y cube by delta cube. Now again put the first term like that only. We will simplify the second term, which is 1 minus minus into 4y square by delta square minus 4y square by delta square minus into plus again minus y power 4 by delta power 4 minus into minus plus 4y cube by delta cube dy. Now as we did in the earlier case, same 2y by delta will be multiplied with every term of this equation, minus y square by delta square also will be multiplied with every term of the equation. So what we will get after multiplying, 2y by delta into 1 is 2y by delta, 2y by delta into minus 4 square by delta square is minus 8y cube by delta cube, 2y by delta into y power 4 by delta power 4 is minus 2y power 5 by delta power 5, 2y by delta into 4y cube by delta cube is 8y power 4 by delta power 4, minus y square by delta square into 1 is minus y square by delta square, minus y square by delta square into minus 4y square by delta square is plus 4y power 4 by delta power 4, minus y square by delta square into minus y power 4 by delta power 4 is plus y power 6 by delta power 6, and minus y square by delta square into 4y cube by delta cube is minus 4y power 5 by delta power 5 dy. And any additions to be made, if there are similar terms we can do addition, and we can write the remaining terms at one place. So 2y by delta and yeah, minus 8y cube by delta cube is also the same, and we have minus y square by delta square, and then here we have 8y power 4 by delta power 4, and here 4y power 4 by delta power 4, it becomes 12. And next we have here minus 4 y power 5 by delta power 5, here we have minus 2 y power 5 by delta power 5, so it becomes minus 6, and the remaining term which is y power 6 by delta power 6. Now integrate this. Integral of y is y square by 2, integral of y square is y cube by 3, Integral of y cube is y power 4 by 4. Integral of y power 4 is y power 5 by 5. Integral y power 5 is y power 6 by 6. And integral y power 6 is y power 7 by 7. Anything to be cancelled, cancel out. So 2 and 2 will get cancelled here. Here 4 ones are, it is 4 twos are. And next 6 and 6 will get cancelled. That's it. So that's the remaining equation I have written here. Now what we will do is uh, substitute the upper limit and lower limit. So when you put the lower limit 0, the entire term becomes 0. So upper limit is delta. So in the place of y square, delta square by delta minus in the place of y, delta cube by 3 delta square minus 2 into delta power 4 by delta cube plus 12 into delta power 5 by 5 delta power 4 minus delta power 6 by delta power 5 plus delta power 7 by 7 delta power 6. So here I'll be left over with 1 delta, and here also I will be left with 1 delta. Here also I will be left with 1 delta, and here also I will be left with 1 delta. Here also we will be left with 1 delta, and here also we will be left with 1 delta. So it becomes delta minus delta by 3 minus 2 delta plus 12 delta by 5 minus delta plus delta by 7. So try to take out the LCM and simplify. You will be getting the answer as 22 delta by 50. So this is how you have to solve for displacement thickness, energy thickness and momentum thickness. It's easy when you can open the brackets correctly and do the differentiation correctly. Okay. Hope you all understood the video. Thanks for watching.